So your task 2 would be something like this with your pin assignment. You don't really need the LED that blinks. Okay, so you need a clock, obviously, and then here I assigned a switch. If you want to reset and start again, this takes a clock. Takes line number 22, which is Q22 here, and then it sends it to your JKs. This is Q. Clock. This clock comes from here, so it comes from the CPU, and you take line number 23. This is a bit faster than 23. Is a bit faster than 23, and then goes to your outputs, and that serves it to all your JKs. Yeah, so I've already built it, and let me show you here before I demonstrate how you can get all these pins. So it's something like this here. Something like this. So if you press the reset button, they go off, and then if you push your parallel input to your finite state machine, if you push it, so it's gonna count 4 beats, 1, 2, 3, 4, and the first LED, and then after another 4 seconds, the second LED turns on. So you press the first one, in 4 seconds it detects the 2, and then in the next 4 seconds it detects the 7. So this is it. This is task 2A. This is 2A. It's fairly straightforward. Okay, reset, 4 seconds, take the 2, another 4 seconds, you detect you detect the 7. So let's reset that and just do it from scratch. Let's just reset that and do it from scratch. Take all those, just delete all of them. And delete all those. Okay. Yeah, delete them. Delete those, yeah. So if you want to do it from scratch, what we're going to do is, what you want to have to do first is make sure that your simulation is fine, build it. So by building it, it's gonna bring all those pins that you just deleted. So you go to your data sheet because you need some sort of a reference. Yeah. Pin assignments. So, as I said before, your Max5 has 40 times 2, which is 80 GPIO pins. This they call it J6, and this one they call it a J7. You can clearly see a G7 here, J7. This is G6. This is J6. So you go to your data sheet, and then you find this. This is your pin assignments for pin numbers for J6. You see it says J6.1, that's J6 pin 1. they all go up to pin 40. Yeah, there are pins that you can't use here, just like 29 and 30. Those are reserved for an input ground and an input VCC, and J11 and J12. So you can't use four of these pins. You can't use here. The same goes for J7. J7 has 40 pins as well. Has 40 pins. J1 up to J40. Still J29, J7, 29 and 30 you can't use. They are VCC and ground. The same goes for J11 and J12. I mean J7, 11 and J7, 12. Those are reserved for ground and VCC. Those are input grounds. But I don't think you necessarily need to worry about them. Just that when you're building and doing your pin assignments, you should make sure that you skip these pins. Just make sure you skip these pins, because you might find that your implementation is not working, but it turns out that you use these pins that are not useful for anything. Yeah, so for this part, for task 2B, task 1B, this part, task 2A, I mean, this is task 2A. Yeah, we're only going to be using J6 and two of the switches, which is S1 and S2, and both LEDs, both switches and both LEDs. So you go to your pin planner and just take all these first ones. You're gonna need, because these A, B, C all the way to H are your inputs. Four pins here. This is the highest number you're using, the highest digit you're using, and E to H, that's the lowest digit you're using. So from A to D, I have my 7, and from E to F, I have my 2. So if you wanna do that quickly, choose pin 2, P2 to get J61. That's P2. Let's do enter. M4, enter. That's L4, enter. Just be careful to skip these. As a clock, that's the internal clock. You're not gonna be signing it outside. This is a clear. It's going to the switch. I'll come back to it. And this is D. That's L4, N3, and N3. We have N3. We also have N2. We have N1, N1. And then G goes to the following pin. M3, M2, and M2, yeah. Alright. So these are just my states. I don't need them, so I can just delete them. Right click those and delete them. Yeah. Right click those and delete them. Delete those. Yeah. So you have your LED. This LED, we say we're not gonna use it. You can remove it. Remove that. And then you have X. X is internal. You're not gonna need it outside. Just delete that. Just make things easy. So this goes to one of your switches, because this is shift or load. This is shift or load. You're going to have to press it down. Put it to ground in order to load your parallel load to the shift register. So your SH should go to one of your switches. I mean, your SL goes to one of your switches. That's going to be S1. Let's say S1. That's R3. S1 goes to R3. S1 goes to R3, and then we said CPU always goes to H5. CPU always goes to H5. This is H5, always goes to H5. And CLK you ignore because it's an internal signal. And then clear, you take that to M9. Yeah. And then you use one of your LEDs to check your inputs. So for 2 goes first. I'm gonna take that to R1, which is LED 1, the LED on your left. That's R1. Yeah, and then 7, I'm gonna give that to P4. P4. Yeah, and that's it. And you close that. So yeah, your A's goes to your first pins. What I did here, so another thing is that when they count these pins, they count from left to right. Yeah, so you find this. This is J1. I mean J6 1 pin 1. So this will be pin 2. Like you see, there's 2 here. For instance, here you can see there's 1 and there's 2 here. So when they count them, they say 1, 2, 3, 4, 5, 6, 7, and so on. So here you can see you have 40, and in this side you have 39. So this is 40, 39, this is 38, this is 37, and so on. So you should note that, take note of that. What else? Yeah, these are your switches. This is S1, this is S2, LED1, LED2. Those are what you'll be using to demonstrate. So yeah, after that you build again. So in the meantime, you should note that your LEDs are if you wanna turn on your LEDs, you need to ground them. So my output here, outputs a 1. Okay, so if I'd send that to an LED just as it is, it wouldn't make a difference because the LEDs by default are on. So if you want to turn them off, you should send a 0. So by default, when this is 0, this one is going to send 1 to the LED. So by default, when this is 0, this is going to send the 1 to the LED. Let me see.